Okay, so this is a continuation to lesson R.2. You should be on page 1.17. The sound cut off at 10 minutes, 18 seconds in, so that's where you need to pick up. Okay, so again, you're watching R.2b to finish R.2 because the voice did cut out at 10 minutes and 18 seconds. So we've got 5x to the negative 4th, y squared all divided by 9z, or I'm sorry, z to the negative 8th, all raised to the negative 3rd power. And now we're going to go ahead and we're going to raise that power to a power. Okay, we've got that negative 3. So remember, we have to raise it to every term in there. So we've got 5 to the negative 3, x to the 12th, y to the negative 6th, all over z to the 24th. Okay, so now what we can do is we can start thinking about those negative exponents. We know we don't want them, we don't like them there, so we have to take care of them. So that 5 to the negative 3, we want that gone out of the numerator. We're going to push that down. Same thing with y to the negative 6, but we're going to leave alone the x to the 12th and the z to the 24th. Those are already positive exponents. They don't need to go anywhere. Okay, so we're going to put those in now and leave them alone. So now what I can do is I can push down that 5 to the negative 3 so that it becomes 5 cubed. And I can push down that y to the negative 6 so that it becomes y to the 6. Now one last step, we don't want to leave that 5 cubed. We know what that equals. So we've got our x to the 12th divided by 125, z to the 24th, y to the 6th. And there's our solution. Okay, moving on. Make sure you have this all down in your notes. All right, now we're going to start dealing with scientific notation. Scientific notation is generally used when we have very, very large numbers or very, very small numbers. It's in the general form n times 10 to the m, where n has to be greater than or equal to 1 but less than 10. And m starts to deal with how we move that decimal place, and we're going to see that in a minute. Okay, m does have to be an integer value, positive or negative whole number. All right, so our first example, views of video. In the first 2 months after having been uploaded to a popular video sharing website, a video showing a baby laughing hysterically at ripping paper received approximately 12,630,000 views. Convert the number 12,630,000 to scientific notation. Okay, so the first thing you should be thinking is, wow, that's a really big number, right? So what we're going to do is we're going to change that to scientific notation. So what we need to determine is, what is our n value going to be? Okay, remember, n has to be between 1 and 10. We also need to know our m value, so how many places are we moving that decimal? So we're going to start with where the decimal actually is. Okay, that decimal is all the way at the very end of that number. And again, we're going to stay in that form, n times 10 to the m. We're going to figure out what n is now. So we're going to take that decimal and we're going to move it until we get a number that's between 1 and 10. So 12 is too big, so we have to keep moving. One more space. We've moved 7 times now. Okay, so our n value is going to be 1.263 times 10. And again, we moved our decimal 7 places, so it's going to be raised to the 7th power. And if the number starts out very large, that m value is going to be positive. Okay? All right, so let's try another. volume conversion. 1 cubic inch is approximately equal to 0.000016 meters cubed. Convert the number to scientific notation. Okay, so first things first, small number. M value, negative. Okay, so let's start by finding that n. We want a number that's between 1 and 10. It can be 1. So let's take that decimal and let's move it over until we get that number. 1, 2, 3, 4, 5. We've moved it 5 places to get us an n value of 1.6. Okay, and so now we have 10, and since we moved it 5 places, it's going to be to the negative 5 because that number started off smaller. Okay, one more scientific notation. All right, so we're going to convert this to decimal notation. So again, look at that exponent. It's a negative. That means the original number was very small. So should we move that decimal to the right or the left? We're going to move it to the left. So you should have 0.0007632. And there it is in decimal notation. Next. Okay, so the exponent is positive, which means the number should be getting larger. We're going to move to the right. Oh, my board is going a little wacky here. Sorry about that. 9.4. Yikes. Let's try again. 9.4, and we're going to move it 5 places. 1, 2, 3, 4, 5. So 940,000 is your answer. And again, that's put in back in decimal notation. Okay, moving on. Distance to Neptune. The distance from Earth to the Sun is defined as 1 astronomical unit, or AU. So that's Earth to the Sun. It is about 93 million miles. The average distance from Earth to Neptune is 30.1 AU. How many miles is it from Earth to Neptune? So express your answer in scientific notation. So what we're going to have to do is we're going to have to take our values, 93 million, sorry about that, 93 million, and we're going to convert that, and we're also going to convert our 30.1. We're going to convert both of those to scientific notation. So 93 million in scientific notation, we're going to move that 7 places. So we have 9.3 times 10 to the 7th power. Now we're going to change that 30.1 astronomical units. And we're going to wind up with a nice, quick, easy 3.01. I should say 3.01 times 10 to the 1st power. Okay, so the fastest and easiest way to do this is to take those two values and multiply them together. So we're multiplying our scientific notation. Eventually. Okay, here we go. All right, so our values, 9.3 times 10 to the 7th, and 3.01 times 10 to the 1st. And we're going to multiply those. So you're multiplying the n values, 9.3 and 3.01. And you're multiplying your 10 to the 7th and your 10 to the 1st. And remember, when we multiply common bases, we add those exponents. All right, so we get 27.993 times 10 to the 8th power. And because that's not in our general form, remember that value has to be between 1 and 10. We need to move that decimal over one more place. So it's 2.7993 times 10 to the, and remember we have to adjust that because we moved our decimal to the 9th. Very good. Okay, so our next video should be good to go. Yes, I guess what I said here was you could also put this into your calculator. It will do it for you. So that's another way to check that work. Okay. So again, I apologize for the splitting up of the two videos. The next video will be done as one whole video, and you should be good to go. All right. We will see you in class tomorrow. Thanks, guys.